Okay, I'm starting recording. So, 50-turn regular coil, the rectangular coil of dimensions, is out of follow position where b is equal to 0 to a new position where b is equal to 0.5, and its magnetic field directed perpendicular to the plane of the coil. Calculate the magnitude of the average EMF that is induced in the coil if the displacement occurs in 0.25 seconds. Okay, uh, so when it comes to these kinds of questions, is average EMF. So average EMF. Now the question is, do you use your? Okay, I'll bring you the two formulas once more. Do you use your delta flux and delta T, or do you use the other one, which is negative d phi over dt? Which one do you use for average?
The first one.
Yeah, the first one. That's correct. Average is always the one with delta. So going on from that, a 50-turn rectangular coil dimensions 5 times 10 cm. Okay. So just give me a guess. If we have a 50-turn rectangular coil, uh, the 50-turn part, how would that be? What val? Okay, your A is, I won't tell you where A is, but like your 50 turns actually changes the A. That's what I'm basically gonna tell you. So your 50 turns is kind of like we have like 50 of these rectangular coils, 5 and 10. And this is times 50 because we have 50 turns basically. So then what do you think your area actually is in this question?
2,500.
Yeah, it'll be uh yeah, 2500, 50 times 50. 2500 centimeters squared, which of course you convert it to meters squared. It's what is it? Well, it's just centimeters squared.
0.25.
It will be, yeah, 0.2. Wait, is it yeah, 0.25 because it's times 10 to the power. If you ever, yeah, that is 0.25. It's just that my brain sometimes I forget, so like I need to. But yeah, you're correct. Times 10 to the power negative 2 times 10 to the power negative 2 meters squared, which is 2500 times 10 to the power negative 4, and then 0.25. For whoever's listening to this recording, if you want to know like how to convert cm squared to meter squared, it's just try to think of it like converting the cm to meters and cm to meters twice because it's squared. Times 10 to the power negative 2 times 10 to the power negative 2. Okay, moving on from that, that's your area, meter squared. Because your area in this case is not only 5 times 10, is equal to 50 times 5 cm times 10 cm because 50 turns. That's your area. Now we have your area now, which is 0.25 meters squared. The next one, now the next one is the magnetic field is perpendicular, so we know your theta is equal to. What's your theta equal to? Anyone?
What?
Your theta.
Delta?
Theta. Your angle.
Theta.
Theta,
Theta.
theta, theta, whatever. Sorry. But yeah, angle.
It's perpendicular.
Hmm.
Or it's zero. The
Yeah, it'll be
angle is
0.
zero. Yeah.
So we know it's 0. And then now the main thing is your B. And B is the one that's changing. Notice that. So what is the change for B? What is the change in B? Anyone?
The change in B is 0.5 Tesla.
Yeah, 0.5 Tesla. Because it's 0. The final one minus the original, which is 0. Which is just 0, which equals 0.50. So yeah, there's that. It's an important nuance that I show you that is delta B in this case because, okay, not in this case it's fine because the order was 0, but sometimes it might be a bit different. But just remember it's delta. In this case, it's delta B because we're talking about the change in flux, and change in flux is delta phi, which of course has to come from a delta B, which is which would be the final minus initial. In any case, we
Yeah.
have this now. So how do we write this down though? How do we make use of this? Sorry. One more piece of information. Uh, the displacement occurs in 0.25 seconds. So then, what does this tell you? Which variable does it tell you about?
Delta T.
Yeah, delta t. That's correct. Just equals 0.25 seconds. So these are your star points. So now, what do you do with this information?
Uh, Multiply the change in B with the area and then divide by the change in time.
That's correct. Sorry. Yeah. Actually, no. Yeah, that's correct. So delta phi would be equal to, because everything else is constant other than the b, it will just be equal to times uh a times delta b times what is it? Yeah, times cos theta, which is of course one. Uh, and then we have delta t, which is zero, which is delta t. So basically, I'm showing you that because we know that phi is equal to ab cos theta, then we can write this as a times delta b times cos theta, and therefore, like what Abdur has said, you would write 0.25 times 0.5 times cos 0, and then over 0.25 seconds. And then yeah, you basically get your answer. So just someone compute the answer for me.
It's just 0.5 because 0.25, 0.25
Oh
cancel
yeah,
out.
that's
So it's
true.
just
You just cancel out. Yeah, that's correct. 0.5 volts. And that's basically it. That's how the kind of question will run. This one you just learn a bit more about the coils, that's all. The turns, I mean. Okay, I'm gonna stop that recording so that it's like a bit easier to like look at.